Hi, welcome back. Another video from me, Cam, and today we're going to carry on from where we left off in the last video. We got through the first time installation wizard of Gaia, and now we're going to look at the actual Smartconsole, which is where you do most of the management and setup of Checkpoint. This is generally the management piece, shall we say. As I mentioned in some of the previous videos, you normally have a management server and the firewall separately. So the firewall obviously does the enforcement. I think historically they've been called enforcement modules, and the management server is where you do the management. You set the rules, you set NATs, you do all the bits that the firewall itself then implements, shall we say. At the end of the last video, just quickly, that error that came up didn't seem to have any actual impact, so we can kind of just ignore that one. Possibly because I'm on a newly built VM machine with not much on it, and so yeah, just okayed and complete that Smartconsole installation. So if you get anything similar to that, I wouldn't worry too much about it. Anyway, moving on. So we're going to log in here, admin, our password, and we're going to log into the IP address we set on the ETH0 interface. Okay, it's going to bring up this fingerprint. You can find this within the CLI of the device, but it's just to ensure that, say, someone had set up a fake Checkpoint manager and they were pretending to be your manager. This is used to verify that this is definitely yours. You know, it's a good security function, and again, because there's certificates used and there's that ICA I mentioned within Checkpoint, that ensures that we know that we are logging onto a valid Checkpoint server that is ours. So I'm going to do proceed there. And it can take a moment. And a moment longer. And there we go. So yeah, we get this pop-up about stuff. Have a read through that if you're bored ever. I'm sure there's a lot of interesting detail for people within here who are new to Checkpoint. We're not going to cover all this in detail, but yeah, let's X that one off, and let's first of all. So this is the name that we gave to the server or the device, the CPAIO Checkpoint all-in-one. And if we just double click into it, we'll see what details we can see here. We can see the IP address assigned to it. Now we've got this secure internal communication that I mentioned, trust established. Well, it is this device that we're on. It's the manager and the firewall. It would certainly be concerning if it didn't trust itself. And then down here we have a separation of network security, custom threat prevention, and management. I'm going to go to management first. And we can see here we're a network policy management server. That means we manage the policy from here, the firewall policy that we're going to push out for the enforcement. We're not a secondary server, we haven't built a secondary server. We can do endpoint policy management. That is for your end clients, your Windows, your Linux, your Mac devices. Very separate part of Checkpoint that we're not going to cover today, or probably not anytime soon, to be fair. Login and status. So you can have a separate log server. What is a log server? We want to keep track of traffic going through the firewall, and we want to know what's happening with it. If something's being blocked, you'd like to know. If something's being accepted and it shouldn't be getting accepted, you want to know that. So yeah, we have a login server as part of this device as well. That is by default, but as I say, you can buy, and it is buy, a license for a separate log server, or you can buy hardware again. So there's that. Identity login. This is another piece of a blade within Checkpoint. We're not going to do that right now. User directory. It doesn't get used in the same way it used to, I would say, because we often don't use LDAP quite so often these days. We often hook into Azure AD more often, or Entra at the time of this. They may have changed the name again in the future, but yeah, that's user directory. Provisioning, This allows you to it allows you to do some sort of central upgrades, shall we say. Again, not my preferred method of doing this. There's more to it with this blade. It's not something I use often, but it's more like a, shall we say, preparatory blade. Let's just move on from that one. And then compliance. This helps you look deeper into your policy, as well as what's the word, shall we say, have some accountability is I think what we're looking for. When changes are made, you need to log against it. For example, this change was made based on change number X, and it was the action was taken by Y. So it's a log trail, an audit trail, shall we say. There are other audit trails within the standard logs anyway, but yeah, some people like to use this. I think it's just a nice heads up for some people to say, are you sure you should be doing this? Everyone's probably been in that situation where someone's made a change and you're running around going, who did this, why did they do that? And often it's harmless as a genuine reason, but just in case someone's done something maliciously, it does happen. So that's what compliance would be related to. And then smart event and correlation unit. So the smart event server itself can often be a separate device, and it's essentially Checkpoint's seam. I'm saying that loosely because it's not quite on the scale of the big enterprise-sized seam solutions. It works fine. It's very Checkpoint focused. I believe nowadays it can take logs from other devices as well. But yeah, it's kind of a seam essentially, and you can add alerting and things like that through Smart Event. Probably something we'll cover at a later date. And the correlation unit is the actual unit that does the brains essentially for generating those alerts and warnings and that sort of thing. It does the compiling of I want an alert when XYZ happens. It does the brains, and then you set that parameter, I guess, in the Smart Event server. I guess similar to how we're looking at the Smartconsole here. The network policy management side is the I want to do this, and then the firewall enforces. So yeah, that's just covering those blades. Custom threat prevention, we'll cover all of these later in a little bit more detail, but they are stuff like IPS, if you've never heard of it, intrusion prevention, anti-bot, antivirus. It's more signature based for IPS and antivirus, so we've seen this type of behaviour before and we want to do something with that. It's bad, block it generally is what you're looking at, or prevent is generally the wording that Checkpoint use. Anti-bot, as you can expect, and looking at the description, connections from hosts up to known CNC or command and control domains or IP addresses, and it blocks those. Threat emulation, threat extraction, they're both to look at 0-day vulnerabilities, i.e. let's take an example, a new Trojan or something has been released into the wild, no one knows about it, but as part of it, it starts making call outs, or it starts modifying files that shouldn't be touched, like within the Windows system directory. Checkpoint will look at the file before it actually executes on your machine and say this behaviour is reminiscent of the behaviour that a bad file takes. This is not activity that your normal workflow would expect, and therefore it will take the action of blocking that file generally. It's a very useful function. Does it have its drawbacks? Absolutely, because often, let's take macros for example as an obvious thing in something like Excel, they can often be flagged, and it has its pain points, but it's there for the right reasons, shall we say, yeah. And then we've got the main piece, access control here. So we'll go through these slowly, and we're just going to start off with the firewall blade, then we probably will go to the VPN blade and probably do a bit more deep dive on that. Application control URL filtering are related to what websites, what applications, that would be stuff more specific, like let's say LastPass or Facebook games for example. They're specific applications that have been built. Again, we'll look into it in more detail. Mobile access is kind of tagged onto IPsec VPN, but it's more for remote access, so user specific, versus this IPsec VPN, which is more for site to sites. So with a remote access, for those not familiar, that's you sat at home creating a connection into your corporate device with a client generally. You can also do it clientless via a web browser, but yeah, that's what the mobile access is. Whereas the IPsec VPN would be, let's say you've got a site in London, you've got a site in Leeds, and you create a site-to-site VPN between generally it's two firewalls or some other type of device for security and privacy between the two sites. Yeah, so it's kind of like creating a large-scale LAN, essentially. Identity awareness, very key piece nowadays. It's often using off the back of LDAP, and the idea is that instead of having to create rules based on IPs, you can do them based upon a user or device, which is obviously very handy if users are constantly changing the machines they're on. It still uses an element of IP addressing though, because it's a mapping rather than saying, oh yeah, I know exactly who Dave is. It's Dave is currently on this IP address. So that's something to consider. And then content awareness, not something again used too often, but it's kind of like you can build your own signatures to look at specific data and take some action upon it. Okay. Just to start off, we'll go with just the firewall though, as that's all we need. So I'll just do a OK here for now. So yeah, when you first come in, this is all you see on kind of the main general page. Where we're going to do most of our work's under security policies. And yeah, by standard, you get the standard policy. This is the name of the policy. If we go up in this top left and we go to manage policies and layers, we can see here is the policy, and it's called standard, and it currently allows you to work on the access control and threat prevention. If we go for an edit, we can turn on more blades. Let's say we don't want threat prevention because we don't need it for now, and we just have the firewall blade. If we click here and edit the layer, so the layers go into the policies, we can add other things, like within this policy we can have an application control and URL filtering piece. We can have content awareness. We could add a mobile access piece to this. Again, for now we're just going to go with firewall. And yeah, we've also got a separate layer here for HTTPS inspection. Don't actually think this can be turned off now. No. What you'll notice with that one though is multiple policies can use this layer. So essentially it's shared. If you had another policy called, let's just say non-standard, standard 2, anything like that, we could use the one HTTPS inspection layer and share it between all of the policies. Okay? Installation targets is pretty key. Let's say on our general page, let's actually go back to it. On our general page we had 10 different firewalls. Yeah. Each firewall may need its own policy because each site or each firewall is enforcing different pieces, and the rules at site A might say, oh, we need access to Facebook because there's a marketing team here, whereas at site B they don't need Facebook access, for example. So you can differentiate that by saying within the policy, if we open back up again, we can say our policy target or our installation target is a specific gateway and it's only for here. Yeah, so that's that piece done. Now let's just close this off. Now if you've never seen a firewall policy before, then chances are you don't quite understand how they work. They are top down. In other words, it's going to look at rule 1, it's going to assess rule 1 before it moves on to rule 2. What I mean by that is, at the moment this rule says cleanup rule, and it says the source is anything, destination is anything, any VPN, any service or application, I'm going to drop it. Basically, this firewall at the moment won't do anything. Any traffic that processes through it is simply going to be dropped. It's not much use. Likewise, changing this to accept probably isn't the best idea in the world. You essentially created a router at that point with no filtering, no access list, etc. So we want to keep the cleanup rule here because we want to allow explicit stuff to be allowed, but anything else that we're not confident about, that we don't know about, we always want that to be dropped and then subsequently open that up. Yeah. So rule 1 at this point, or the very bottom rule should I say, we're going to right click here, we're going to add a section title above, and we're just going to say cleanup rule, and this should be your bottommost rule. Let's just do that. Okay, and the section title then allows you to just hide that away. So the next thing we want to do is focus on the management of the firewall. If we add a new rule above and we add a new section title above, we're going to say firewall management. Now this doesn't, yeah, let me think of the wording on this. There's more rules to be added when you have a separate manager and firewall device. Because this is all in one, there's certain rules that we absolutely don't need here because it doesn't need to, there's no need for the manager to speak to the firewall and vice versa. There's also something else called global properties, which we'll cover a little bit later, and they kind of help with this, but there's a lot of scenarios where you may want to turn them off to allow more granularity in those rules. So we're going to change this one to an accept. Yeah. And what's it going to contain? So I'll actually name this rule. I'm going to call it, let's just call it admin management access. Okay, so what am I thinking about when I'm creating admin management access? Well, let's have a look at what we've got in our firewall. I'm going under network management here. At the minute we've only got one network, and this is actually going to be our external network, i.e. the one that takes us out to the internet. It is my home LAN network in this scenario, but we're going to use this network to go from the firewall out to the internet. Now, I mentioned that some people may have noticed there was a problem with this. You can't build a firewall, or at least a checkpoint, with one interface. You're going to want at least two interfaces, essentially an inside or a LAN and an outside for your a WAN for your ISP leading interface, shall we say. One of the other things you'll notice here is the topology is undefined. Double click on this, we're going to go under modify, we're going to override, and we're going to say this is the internet external. Okay, we're also going to tick this piece, which is perform anti-spoofing, we're going to prevent, and we're going to log. What this does is it looks and does a calculation and says, well, I know that this interface has 192.168.178.0/24 encompassed in it. And for those of you not familiar with why I've said 0 and /24, that I suggest you go and do some research on subnetting. A quick rundown: any hosts that start with 192.168.178 from 1 to 254 will be allowed to come into this interface, as well as anything that's outside of other interfaces that are defined within our checkpoint, because it's the internet leading one. Again, I hope this makes sense. It will make more sense as I create the other interfaces, but yeah, we're doing anti-spoofing to prevent traffic that shouldn't be coming into this interface from doing so. It's essentially a security parameter. We'll click OK there. So that now says external. Okay, so the next question is, we've got that one interface, we're definitely going to add a second, but do we want to allow, actually not there, do we want to allow any to our firewall and manager? Hopefully the answer you've come up with is absolutely not, no way, this is a terrible idea. We don't want the world to access something that we're using to protect our enterprise. This would obviously be a terrible idea. Realistically, we may want some public IPs, but only public IPs that we know of. Generally, again though, we're probably not going to do this. Unless you have maybe like a third party that manages them, you know that they've given you those public IPs, and you're doing restrictions here to ensure that only certain ports are allowed. In our scenario, we're probably going to create an inside network. So let's go here, we'll hit this little star, which is new. We'll create a network here, we'll call it net 192.168, let's go 179.0. We'll put in the actual network range here. We'll give it a net mask, which is a /24 or 255.255.255.0, and we're just going to hit OK on that. Now what we're saying here, this is a better rule. We're saying that anyone in this network range, so 192.168.179, 1 to 254, can access our checkpoint firewall or manager in this case, and we're going to finish that piece off, say over any service, so any port. Again, if you're not familiar with ports, please do some research on that, but it's things like HTTP, HTTPS, SSH, and I'll go through the list of what I suggest afterwards, but at this moment we're saying any, and we're going to accept that. Again, is this a good rule? I'd say no, and the reasoning being behind that is that generally you only have a limited number of people that actually require the access to the management server. It might be the IT team, it might just be a network team, it might be a security team. But again, we should be as granular as we can be with this rule, because it's giving them access to the entire firewall policy, which is designed to protect. Yeah, and you know, the less people that have access to something, and hopefully they're people that are skilled and have the knowledge within something, then the less chances there are of mistakes happening or anything malicious happening, right? So even though we've got this entire network here, I don't think this is a good idea. We're going to say instead, let's take a host, let's go host underscore 192.168.179.10. We'll just copy that in here. No net mask required because it knows this is a host object. I'm going to say OK there. Now we're only allowing this single host, which means if you're not on that host, you cannot get to this device. That sounds 100 times more secure to me and a lot better. Yeah? Right now, because I've got some other pieces of work to do to secure this, I'm actually going to add the network 192.168.178.0, which is actually my outside, just so I don't cut my own access off. Okay, there. Alright, so now we've got some level of lockdown and we've got an explanation why. Our destination is this device we've already discussed. We're not using a VPN anyway, so we'll just leave that be, we're not too bothered. Now the next part, do we want to allow services to any? No. Again, that should be the answer. We want that granularity, don't we? So what access would you need? Let's go into here. So Checkpoint, when you connect to the management server, uses two, shall we say, important ports. We use CPMI, which is port 18190, add that, and we use CPM 19009, I do believe, when it comes up. Yep, there we go, CPM. Okay, and that actually allows you to get the connection into the Smartconsole from your local device using this GUI, this graphical user interface, using the Smartconsole. Okay, so we definitely need those two. I also know that if we go to logs and monitor, which we'll do later on, that can leverage HTTPS. So we definitely want to allow HTTPS. That would also allow the access to the web UI, which is on 443, which we saw obviously in some of the earlier videos. You HTTPS to this device. Anything else? The final thing that jumps to mind straight away is SSH. This allows us access to the CLI. And we'll just pop that there. Okay, so we're restricting down who from where someone can reach this device that we're currently on, our smart console, our firewall, our management server. We're not too bothered about VPN at the moment, it's not involved. We're saying you can only access on these ports, these key ports for Smart Console, HTTPS, and you can SSH to it. We're going to accept that, and we're going to log it as well. Yeah, we want to see who, or rather when, they've tried to access with these ports, and that's going to pop up in our logs and monitor. Again, accountability and a wider understanding of if maybe something's not happening that should be. And then our other rule is our cleanup rule. Any, in other words, anything else, any port as well, so anything else, we're going to drop. A key point that we need all the time is to log this. Because if someone comes to you during the working day and says, I'm part of, again, the marketing team, I can't access LinkedIn, we can look at the logs from this rule. Now we're logging and say, oh yeah, you're being dropped. I need to create a rule to allow that. Go through our change process, etc. And then we can get that rule built. Okay? So there's one other key rule, and I'm going to give it its own section just because we can. Let's add a section title above here. I'm going to call this the stealth rule. And the reason we're going to call this the stealth rule is it's designed to hide traffic, or rather to log traffic coming directly at your firewall. And we like to have it separate because it gives us an idea of what's going on directly to the firewall. It ensures that the firewall doesn't respond as well, which this is probably a key point. There's other options down here. If we go on more, and you've got reject, for example. Reject means that the traffic won't be accepted, but it will actually respond and say, yeah, I can see you've tried to send a ping to me, for example, but I'm not accepting that, essentially. We don't want people to know the IP address of our firewall. So we're going to create this explicit drop rule, and we're going to log it just in case. The other two down here, not covered, not used very much anymore these days, but maybe covered in a later video. Okay, so we've got our management access rule, we've got our stealth rule, and we've got our cleanup rule. Yeah. Now that we've got this first basic policy in place, we're gonna do a policy install. Yeah. So policy install does a verification of the policy, but we're going to do it separate just to show you. We've got this verify access policy, we're going to select the policy, I'm going to hit the verify button, and then it's going to publish, which is essentially save. So yeah, before you can actually push or install the policy, you need to save it. We're going to publish, and then it's going to verify, and verify is essentially going, does the policy make sense? So if we look down here, I'm hoping some point soon we'll see a verification take place. There we go. Policy verification of standard policy. Oh, it doesn't like it. What have we done? Ah, interesting. So it's not even letting me verify the policy because it's saying there is only one interface defined for object CPAIO. And as I mentioned, we need at least two interfaces defined here. Okay, so let's go back to gateways and servers. We'll double click. So one of the things we can do is we can hit actions, new interface. We're going to name the interface ETH1. We're going to put the IP address 192.168.179.150. It's again going to be on a /24. We're going to modify here. We're going to do an override. And so I can speak about these in a bit more detail now. So network defined by interface and IP and net mask. So what that is essentially saying is anything in 192.168.1790/24, so 1 to 254 in that last octet, we're going to allow traffic to come into this interface, yeah, from those hosts only. Okay. Now that isn't ideal, I guess, if you have an interface that has multiple networks behind it and they all eventually lead into this interface. So you have the option there of using specific, where we can create a new group, for example, network group, and we can say this is ETH1 anti-spoof. It's just the name of the group, and within here we'd create a new network, and let's just call it net 192.168.180. 0.255.250. Okay. Now the important thing is, this would now only allow traffic from that network. Massive problem, right? Because you need to allow that as well. So you do need to have all of the networks you're expecting to allow into this interface. So we'd have to add net 192.168.1790, 192.168.1790, 255.255.255.0. I did think I'd created that, but why didn't I say it? Let's just cancel that. Just type in here. Ah, there it is. Okay, and I'm going to just clean this up so they're the same. Okay, so we've now got two networks, and we're saying behind this interface lives these two network ranges. If you see traffic sourced from them, that's good, that's acceptable. Anything else, no, shouldn't be coming in this interface. Okay, and we can OK there, perform that. We want to do a prevent, and again we want to log it, and the log will show us when there is traffic trying to get into this interface that isn't in this group at this point. Okay, now I've only added two networks in here. Imagine you added hundreds. You were regularly adding new networks into here. Bit of a pain, right? Probably not the best way to manage this. So it took them a while to get here, something that other vendors did, but my preference these days is to use this one, which is networks defined by routes. What that means is, if you have a route saying to get to 192.168.180/24, go to 192.168.179.10, which could be that other router we've mentioned, you know, then it will automatically recognize that, well, 192.168.179/24 lives behind ETH1. Perfect. So I know that traffic from 192.168.180 must come inbound on ETH1. Yeah. Now the other option we've got other than prevent here is detect, and that is essentially the cheat if you're unable to accurately identify what networks live behind the interface. This isn't good. It can lead to other problems, and that's to do with asynchronous routing, which we may touch on, well, we'll definitely touch on at a later point, but we don't want asynchronous routing. We always want the routing to be synchronous. Asynchronous routing can have impacts on the way the firewall works, and not in a nice way. And it can also mess up your network in general, so we don't really want asynchronous routing. So I would advise, as I say, go network defined by routes and perform anti-spoofing and set that to prevent. I'm going to hit OK there, I'm going to hit OK there, and now we've got our second network defined by routes. Okay, And just to blow all this up, I'm gonna delete that now and show you another way of importing the interface. We okay there? So we're gonna go here and 192.168.178.150. We'll go to admin. Okay, we're going to add a new interface here because it's going to need to be actually added to the firewall as well. I'm going to add it. We're going to say it is a... I cannot add it. And this is because I haven't actually created it in VMware. So I'll have to do this piece off of the video and we'll come back here and I'll show you the next section. So I think I'll leave the video there. I've covered quite a few steps. I'll show you the creation of it in, sorry, not VMware, within Hyper-V, and yeah, we'll come back and look at that on the next video. Hope this was useful for you guys, hope it was informative, and I'll see you in the next video.